Hello class, in this video I'm going to answer problems 13 and 14 from the Module 5 homework. So in this example, it looks like we have data for rooms that are carpeted and uncarpeted, and our research wants to determine if the rooms with carpet have more bacteria. So the null hypothesis would be that the two rooms have the same amount of bacteria, meaning U1 equals U2. So our choices have to be either A, B, or C. And then we want to know, is carpeted room, does it have more bacteria? Meaning, is U1 greater than U2 in terms of bacteria? So choice C would be my answer, right? Carpeted rooms have more bacteria than non-carpeted rooms. Check answer. Looks good. Next, it says determine the p-value. So let's take this data and open it in StatCrunch. And we want to basically press stat, t-stats, two samples, and we have the data. And carpeted is column 1, uncarpeted is column 2. And let's see here. We want to do a hypothesis test that they're equal, and then the other one would be U1 is greater than U2, right? If I add U2 to both sides, U1 is the carpeted rooms greater than bacteria uncarpeted rooms. Press compute. My p-value is the 0.2988. And I put that in here. We can round 3 decimal places, so let's call this 0.299. Okay, check answer. Okay. Okay, so now that we have the p-value, we want to compare this to some level of significance. So the level of significance is 0.05. Our p-value is greater than 0.05. So if the p-value is greater, we do not reject. So the choices are either A, C, or D. So if we do not reject the null, that means we're saying carpeted and uncarpeted have the same amount of bacteria, right? So there's not enough evidence to conclude that carpeted rooms have more bacteria. But we're picking this because we do not reject the null hypothesis. And that means that we're saying U1 equals U2, or the amount of bacteria in carpeted is equal to the amount of bacteria in uncarpeted. And when I say amount, I really mean the mean amount. Check answer. Great job. Let's move on to question 14. All right, so question 14, we have to start by doing box plots. So we click on our table. We got tax rate for a female, tax rate for male. I'm going to open this in StatCrunch. And let's see here. You know what? I don't like this. See how it says tax rate? When I do the StatCrunch calculations, it doesn't, I won't know is this tax rate for male or female. So I want to just add F, so I know that's tax rate for female, and I'll add M, so I know that that's tax rate for males. And now I can do, I can answer some questions. All right, so let's see what we have here. First, we'll do the box plot. Let me go back to my data. If you press graph, box plot, the first one I'll do would be the females. I want to draw my boxes horizontally, and I want to see the median. Press compute. So that's tax rate for females. And then we'll do another one, graph, box plot, tax rate for males. Again, I want the median, and I want to draw the boxes horizontally. So right away, if this is males, females, I can see that the median for males is 10%. Median for females is like 12 or 13%. All right, so it looks like it's greater for females. And let's see if we can match up our box plots to what we were given here. So I'll take a moment to compare. So I did notice that the males median again is at 10, and there's an outlier that's just past 30 for the males. The females have no outliers. Their tax rate's about 13, and the end of their box plot goes to about 26. So I believe that that was choice A, right? 21, 22, 23, somewhere around here, 26. There's my outlier. Next, it says, does there appear to be a difference? Well, it looks like the female median tax rate is a little bit greater than the male. So I'll say yes, because the female appear to be higher than males, right? Female, male. See the straight line is males below 10, females is above 10. Check answer, looks good. Then it says explain why a hypothesis test may be used. Okay, let's see what our choices are. So I checked that each sample size is large, each sample size is small relative to the size of the actual population. Sample is simple, random, and the sample is obtained independently of each other. Okay. Next, it says to test whether the tax rate for females differs from males. So it doesn't say greater than or less than, just says differs. So this is the mean for males and equals the mean for females, right? That'd be the null hypothesis. And then the mean for males does not equal the mean for females. That's the alternative hypothesis, right? We check answer, looks good. Next, it says find the test statistic. So if we take our data that's in StatCrunch, I'm going to close this, and I will do, again, t-stats. We have two samples with data, right? This was females, and remember, I added that little F there, so I know that that's tax rate for females, and this is tax rate for males. I added the M there, right, earlier in the problem. And we're doing a hypothesis test, and wait a minute. If U1 is males, I reversed this. That's tricky. See, I almost made a mistake there, right? Remember, UM represents the male, so that means my U1 is male, or my mean one. So my first sample has to be the males, my second is the females. And we want to see if the male does not equal the females. Right, and let me check the wording one more time. Right, this is my hypothesis test. UM equals U2 or U1 equals U2. U1 does not equal U2. And there we go. Right, I press compute. Here's my p-value, 0.317, and the t-stat. So let's enter that here. And they say go 2 decimal places. So that should be 1. Check answer. Good job. And then the last thing we need is the p-value, which is this 0.317. I think we're almost done. And we go 3 decimal places. That looks good. Last thing. So since my p-value is greater, what's my level of significance? Where are we testing that? Here it is. 5%, right, or 0.05. So my p-value, 0.317, is greater than 0.05. So we do not reject. So that means we accept that male and female would be equal. So I press do not reject. There's not enough evidence to suggest that the tax rate is different for males and females. We get the excellent. Very good. Thank you for watching. I hope this is helpful.